A tank contains 20 kilograms of salt dissolved in water with a total initial amount of 5,000 liters of salt water mixture. Salty water enters a tank at the rate of 25 liters per minute, containing 0.03 kilograms per liter of salt. The solution is mixed and drains from the tank at the rate of 25 liters per minute. So here we have salt water that's entering this tank. It's entering the tank at the rate of 25 liters each minute. We're assuming, of course, that this is a uniform rate, which means that in half a minute or 30 seconds we will have half of 25, or 12.5 liters entering the tank, and so on. Now let's consider the rate at which salt is entering this tank. We're assuming, of course, that the salt is uniformly dissolved in the water that is entering the tank. We see that this salty water contains 0.03 kilograms per liter of salt. In other words, 1 liter of this salty water entering the tank contains 0.03 kilograms. And we know that in 1 minute 25 liters of salty water enters the tank. So that means that 25 times 0.03 kilograms of salt will enter the tank each minute. In other words, 0.75 kilograms of salt enters the tank each minute. Now again, this is a uniform rate. That's the assumption here. So in 1 minute, 0.75 kilograms enters the tank. In 2 minutes, 2 times 0.75 or 1.5 kilograms will enter the tank. In 30 seconds or half a minute, well then half of this number of kilograms will enter the tank. Now we're given that initially there is 5,000 liters of salt water mixture in the tank. Now we're also given that the solution is mixed and drains from the tank at the rate of 25 liters per minute. So salt water leaves the tank at the rate of 25 liters per minute. That means that the volume of the tank remains constant. We have the same amount of water entering per minute as leaving per minute, or per any unit of time for that matter. So the 5,000 liters is actually constant. Let's suppose that at any time we have S kilograms of salt in this tank. So this S is a function of time. So the amount of salt in the tank varies with time because we have salt water constantly entering this tank. We also have salt water leaving the tank. But you will see that as time goes on, the amount of salt in the tank actually increases. Initially, the amount of salt in the tank, that's S at time 0, is 20 kilograms. This solution is mixed, so that means that the salt is uniformly distributed through this salt water. Now to answer these questions, we are going to get S as a function of time. We're going to set up a differential equation involving S. Let's look at this situation when time is equal to t, any time t. Well, this is the same as what you saw already. The amount of salt in the tank is just S. S is a function of time. Well, at some time t, the amount of salt in the tank is going to be S of t. We already saw that the amount of salt entering the tank is 0.75 kilograms per minute. And we saw that the amount of salt water leaving the tank is 25 liters per minute. Let's consider a time delta t later. Very small interval of time delta t later. So the amount of salt in the tank will be S of t plus delta t. Let's look at the salt concentration in the tank at the instant when the time is equal to t. Well, that's the amount of salt in the tank, which is S at time t, divided by the volume of the tank. Remember that the salt is uniformly distributed through the salt water because the solution is mixed. So S over 5,000 is the amount of salt in 1 liter of this solution. How much salt flows into the tank in a time delta t minutes? Well, we know that 0.75 kilograms flows in 1 minute. So in delta t minutes, we just multiply 0.75 by delta t. Of course, delta t is a number that's probably a lot less than 1 minute. So it's some very small fraction of 0.75. How much salt flows out in time delta t minutes? Well, we know that in 1 minute, 25 litres of salt water flows out. So in delta T minutes, 25 multiplied by delta T litres of salt water flow out. But each litre of salt water contains S over 5,000 kilograms of salt. So the amount of salt that flows out in time delta T minutes is got by multiplying 25 times delta T by S over 5,000. It has to be said that this is only an approximation, because S of T does not remain constant during a time interval of delta T minutes. S of T is changing. But as delta T goes to 0, as we make this time very, very small, then the approximation, this wiggly equal sign, becomes exact. So here's an equation linking the amount of salt at time t plus delta t and at time t. The amount of salt at time t plus delta t is the amount of salt is approximately equal to the amount of salt at time t plus the amount of salt that flows into the tank in time interval delta t. Actually, this is an exact amount because the rate is uniform for salt entering the tank. But then we have to subtract off this approximate form, which is the amount of salt that which is approximately the amount of salt that leaves the tank during time delta T minutes. Now we can rearrange this to get this expression on the left hand side. We just bring ST across and we divide everything by delta T. So we divide all of this here by delta T. So we get 0.75 minus this thing over delta T, which will leave us with minus 0.005 times S of T. To make this approximation exact, we take the limit as delta T goes to 0. But we know that the limit as delta T goes to 0 of this quantity is just the definition of the derivative of S with respect to T at time T. So now we get the differential equation ds dt, or the rate of change of the amount of salt in the tank with respect to time, equals 0.75 minus 0.005 times S of T. In general, ds dt is the rate of salt flowing into the tank minus the rate of salt flowing out of the tank. In this problem, the rate of salt flowing in the tank is a constant. It's 0.75. But the rate of salt flowing out of the tank is the rate of salt water flowing out of the tank, which is 25 litres per minute, multiplied by the concentration. The CONC means the concentration of salt in the tank at time t. And that concentration is given by the amount of salt in the tank at time t, which is S divided by 5,000. So we have 25 times S over 5,000, or 0.005 S.